So this is an example of an exponential function. And I could write that down as the amount of bacteria after X hours is 2 to the power X. Now, what does an exponential function look like in general? Well, an exponential function is a function of the form. In this case, I used b. I'm going to use a lowercase f for this function. It's f of x equals some number raised to the power x. In this case, my number was 2, right? But it could be a different number. But it can't be any number. It can't be anything. This number here has to be positive, and it can't be equal to 1. So as long as it's a positive number not equal to 1, this is what we call an exponential function. And it's used to model things like growth rates. They use it to measure the spread of the, you've probably heard that the coronavirus has exponential growth. The amount of cases grow exponentially. Radioactive decay. When things decay, they can decay at an exponential rate. So radioactive substances and things have this behavior. So let's just look at some other examples and just make sure we can identify what is and what is not an exponential function. All right, so here's my examples. Well, let's look at this first one here, 4 to the x. Let's see, does it match this description? Well, it's something raised to the power x, so that's good. Is that something positive? Yep, 4 is positive. Is it not equal to 1? Yep, 4 is not equal to 1. So yes, this is an exponential function. What about the next one here, x cubed? It looks like it's got all the ingredients, right? 3 is positive, it's not equal to 1. The problem is that the x and the 3 are in the wrong place, right? Exponential function has to have the variable in the exponent and the number down here. This is the wrong way around. So that is not an exponential function, and we know what kind of function this is. This is a polynomial. Sometimes we call this a monomial because it's a polynomial with only one term. But it's not an exponential function. That variable has to be in the exponent. Let's look at the next one here. Well, we got the variable in the exponent. This number is not equal to 1, so that's good. Problem is, this number is not positive, right? So it fails this condition over here. That b is -5 here, it's not positive, so that actually does not qualify. Let's go over to this one. The square root of x. Well, you might say, well, how could that possibly be? You might try saying, well, this is the same as x to the 1/2. We know that's true. But then we run into the same problem we had over here. For the same reason x cubed is not an exponential function, neither is x to the 1/2. So, no. What about 1 over 2 to the x? Well, it looks like it's not really close yet. I mean, it's got 1 over, so how do we fix that? Well, we know that 1 over 2 to the x is, I can write this as 1 over 2 to the power x. The reason I can do that is because we know that when you do this, the x comes to the numerator and it comes to the denominator, right? 1 to any power is just 1, right? So that just makes the 1 up here. And 2 to the x just makes the 2 to the x down here. So when I write it like this, I see that it is an exponential function with b equal to 1/2. Right? So I got 1/2 to the x power. That works because 1/2 is positive and 1/2 is not equal to 1. So this is actually an exponential function. I just had to rewrite it a different way. What about 8 to the -x? Well, that doesn't look quite right because I got a negative sign here, but can I rewrite it in a way that that negative sign doesn't appear? Well, we know that from properties of exponents that when you have a negative exponent, you can make it positive by moving the quantity to the denominator. So this is the same as 1 over 8 to the x. That's just from properties of exponents. And then we can do the same thing we did here. 1 over 8 to the x is the same thing as 1/8 to the power x. Okay, so these are just some examples.